Chapter 8, Hypothesis Testing. In this chapter, we're going to be looking at claims and trying to decide if we should accept the claims or not accept the claims. This is what we call hypothesis testing. Here are the objectives for this chapter. As you can see, we're going to be using a couple of different types of tests to decide if we're going to accept or reject the claims. And then we're also going to be looking at the relationship between our errors and the power of a test. There are three methods used to test hypotheses: the traditional method, the p-value method, and the confidence interval method. In section 8.1, we're going to be looking at the traditional method. In section 8.2, we'll focus in on the p-value method. And then lastly, the confidence interval method will be found in section 8.6. A hypothesis testing is a decision-making process for evaluating claims about a population. The researcher must do a multiple amount of steps in order to decide if they should reject or accept the claim. In our course, we're going to be simplifying this down to 5 steps. The statistical hypothesis is a conjecture about that population parameter, an educated guess. It may or may not be true. The null hypothesis, which is symbolized by H sub 0, is that statistical hypothesis that states that there is no difference between the parameter and the specific value. Now, the alternative hypothesis, symbolized by H sub 1, is that hypothesis that states that there is a difference between the parameter and the specific value. When you're writing your hypotheses, you have to consider what type of test you're working with. Now, if you know that it's a two-tailed test, then we're always going to have the null hypothesis equal to the value that's already been given. And then your alternative hypothesis becomes that it is not equal to that value. You want to see if there's a change, but you're not concerned about whether it's a greater change or a less change. You're just concerned about, is there a change at all? Now, the right-tailed test is where, again, you're looking at the null hypothesis as the value that's given, but now we want to see is the change increasing that value that was given. And then the left-tailed test is where you're looking at it where it's less than. Here is a situation that talks about wanting to do research. A medical researcher is interested in finding out whether a new medication will have an undesirable side effects. The researcher is particularly concerned with the pulse rate of patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after the patient takes the medication? The researcher knows that the mean pulse rate for the population under study is 82 beats per minute. Here is where we're going to first identify what the hypotheses are. In this situation, the null hypothesis would state that the beats per minute do not change. They're equal to 82. Now, the alternative hypothesis would then be, it says it doesn't equal 82, whether it increases or decreases. So we'll use the equal to or not equal to symbol. This is called a two-tailed hypothesis test. In situation B, a chemist invents an additive to increase the life of an automobile battery. The mean lifetime of the automobile battery without the additive is 36 months. You will notice that we're going to keep the null hypothesis as an equal sign. And then the alternative hypothesis is what we are wanting to compare. We want to see if it increases. Giving that additive, will it increase? So using the greater than symbol. We call this a right-tailed test. Now, in situation C, a contractor wishes to lower the heating bills by using a special type of insulation in the house. If the average of the monthly heating bills is $78, her hypothesis about the heating costs with the use of the insulation are, so we want to say it's equal to 78, no change, and then the alternative hypothesis means we're going to go at the less than mark. This is called the left-tailed test. When a researcher conducts a study, he or she is generally looking for evidence to support the claim. Therefore, the claim should be stated as the alternative hypothesis. A claim can be stated as either the null hypothesis or the alternative hypothesis. However, the statistical evidence can only support the claim if it is the alternative hypothesis. Statistical evidence can be used to reject the claim if the claim is the null hypothesis. After stating the hypothesis, the researcher's next step is to design the study. The researcher selects the correct statistical test, chooses an appropriate level of significance, and formulates a plan for conducting the study. The statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. The numerical value obtained from a statistical test is called the test value. In the hypotheses testing situation, there are 4 possible outcomes. In reality, the null hypothesis may or may not be true, and the decision may to be rejected or not rejected on the basis of the data obtained from a sample. There are 2 different types of errors that can occur from this. Type 1 error occurs if one rejects the null hypothesis when it is true. Type 2 error occurs when one does not reject the null hypothesis when it is false. On this next slide, you'll notice the situation that can happen. Up at the top, you've got the null hypothesis is true, but yet the researcher says we're going to reject it. That is where we call that the type 1 error. Now here is where we say the null hypothesis is false, and we reject that null hypothesis. That's a correct decision. Likewise, if we have the null hypothesis is true, and we do not reject that null hypothesis, then it's a correct decision. And here's type 2 error. We have a false null hypothesis and we do not reject it. That's a type 2 error. I can relate this to when you're talking about going to trial. You either are going to be found guilty or innocent, whether you did it or didn't do it. So here we find it's true that the person, we want to look at if the person did it by the evidence that is given. So if the evidence is strong, is convicted in most cases. If the evidence is weak, then acquitted in most cases. Again, there's always some changes there. This is the same is true for the null hypothesis. We'll reject or not reject. The only way to prove anything statistically is to use the entire population to be able to decide what we're going to be doing.